Kinematics. Here is an interesting example where the object is starting from the left side of the origin. I hope you find it interesting. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is another very beautiful question based on displacement along a straight line. In this playlist of kinematics, we have taken basic foundation-based questions which will help students to understand the topic and get ready for higher level of mathematics. I'll encourage all these students to watch some of the videos from the playlist. That will help them a lot. The question here is, consider a particle P traveling along a straight line such that its displacement s meters from a fixed point O t seconds after passing through O is given by s equals to minus t square plus 4t minus 3. The graph of s against t for t between 0 and 5 is given. Right? Normally, you may have to sketch this graph, right? So that part is not very difficult. For any parabolic equation, you can sketch a parabola. And that is why, to save time, we have already given you the graph. Based on the equation and the graph, here are the questions for you. Discuss displacement and total distance traveled at key points. We need to understand what should be the key points. B. Find the initial position of the particle. Initial position is when t is equal to 0. C. Identify the time interval when particle is to the left of O. So O is your reference point, right? To the left of O really means that the displacement is negative. D. Represent the information on a motion graph, a straight line. So this is a 2D representation when we draw a parabola on a motion graph is also called 1D representation, right? One dimension. So like on a number line, right? We will represent with reference to the point O. Now that is a question for you. In earlier video, we had taken a similar question. However, the object started from the origin itself. Here you will note that the object starts from negative value. So displacement is less than 0 at t equals to 0. Make a note of this. Perfect. So that becomes second example on this particular series, which will help you understand the concepts better. The first one, which we did earlier, is right here. As I was saying, the object starts from the origin with a given equation, s equals 60 minus t square, right? Before we begin, let's look into some basic definitions. Many times, that is also a part of communication in such questions. A particle P is defined as an object with negligible dimensions, right? Where the rotational forces and air dynamics, like frictions, can be ignored. Mass of the particle is concentrated at a single point. All objects in our examples will be considered as particles. Displacement will be represented by s of t is the position of an object with respect to the reference point, normally referred to as origin O. Now, about displacement, when is it negative? When is it positive? That is very important to understand. So always you're looking with reference to the origin, right? So if displacement s of t is greater than 0, that means you're on the right side, correct, of the origin. And if displacement is 0, you are at the origin, correct? And if it is less than 0, then P, the point of the particle, is on the left of the origin. Clear? So from the graph also, if you have y value, which is negative, it means that you are on the left side of the origin. Y value gives you the position in position time graph. When you're measuring distance, total distance traveled in the given duration, all the displacements should be added. So the absolute value of the displacement should be added since distance is a scalar quantity, not a vector quantity. So distances are always positive. So every piece of displacement, whenever the direction changes, should be added. Motion graph can be represented in 1D along a straight line or 2D on XY plane, right? Now let's begin answering the questions. The very first one was to graph the displacement and time, right? Rather get the values. So we are given the equation s equals to minus t squared plus 4t minus 3 and s is between 0 to 5. You have to figure out what are key points, right? This was what are the key points. Now for any function, key points will include what? So definitely looking into the interval, the endpoints are definitely part of key points, right? So let's make a note. First, endpoints. Beginning and end, right? They are key points. Second, we look into intercepts. In this case, since it is time, so let's say t-intercepts. Right. So wherever the graph crosses the horizontal t-axis, the independent variable, right? Also the displacement intercept, or you can say y-intercept. So I'll write s-intercept. And turning points. So at turning points on the displacement time graph, the velocity is 0, the direction changes, right? So these are the key points. Let us identify the key points on the graph itself. So starting point and the end point. This is at t equals to 0 and t equals to 5, right? And then we have the turning point, right? And then we have the t-intercepts. The starting point is also the s-intercept, displacement intercept. So those points become the key points, right? So we can write down time for these key points, and the time will be t equals to 0. And then this point is on the scale 1. And then we have the other one at 2. And then we have at 3. And the last point is at 5. Correct. So these are your key points on the graph. Now for each key point, substitute the value of t to find displacement s. Is that clear to you? That is how you'll calculate displacement. And then how will you calculate the distance? Distance is positive. Displacement can be positive or negative. Is that clear to you? Right? Okay. So displacement basically is position. So let me also write this here as position. So when s is 0, what is the displacement here? Just plug in 0 here, right? You get minus 0, plus 0, minus 3, right? So the displacement is minus 3. You get the idea. So that is your displacement, minus 3, means from the origin, it is 3 units left. You get the idea. So that is how you have to interpret. You get the idea. Next one. When you substitute 1 here, you get minus 1, plus 4, minus 3, right? And that gives you 0 as indicated here also, right? You could read from the graph. At 2, plug in the value 2 here, right? So you get minus 2 squared, let me write down this time, plus 4 times 2 and minus 3, right? So 4 times 2 is 8, and from this we have to take away 5. That gives us the value at 2, which is minus 2 square is 4, right? So minus 2 square is 4. and this is 7, and so that gives us the value of 1, correct? And when you plug in 3, then what do you get? Minus 3 square plus 4 times 3 minus 3, and that is equal to 0. And if you plug in 5, you get minus 5 square plus 4 times 5 minus 3, right? Minus 5 square minus 25, and then this is 20, so minus 5 and minus 3 gives you minus 8, correct? So that is how you can see that this point here is at minus 8. Perfect. So we get our displacement. Now, from here, how do we calculate the distances?
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
So I hope from this situation, you can always write down the distance traveled during the given interval of time, correct? I'd like you to fill up these values for distances. Remember, distances are always positive. So you have to add the absolute value of displacements in each duration of time. Perfect. Now this is how you do it. I'm now taking all these values. We know these displacements at different intervals. We'll take them on a fresh page and then calculate the distances, right? So we calculated time at the critical value 0. It started with minus 3. This is really a position, right? And at t equals to 1, the position was 0. That means it was at the origin itself, the starting point, I should say, right? So, point of reference. Now, in the beginning, it is 3 units to the left of point of reference, right? So, in next second, it moved up by 1 unit, positive value. Then, it came down to 0, back to the point of reference. And then at 5, it moved to a position which is minus 8. So, these are different positions. When we talk about distances, these are all positive. We have to see how much distance has been covered, right? So, of course, when you just start, the distance is 0, nothing has been covered. But then you move from minus 3 to 0. You get the idea. You are moving from minus 3 to 0, right? So, this value is absolute value is minus 3 and it gives you 3. Makes sense since you are now covering a distance of 3 units coming back to the origin. You started 3 units on the left side, came back to the origin, right? On a motion graph, it can be shown like you started from 0, right? So at the time t equals to 0, the position was minus 3. Do you see that? So displacement s was minus 3 and distance covered is 0. Right? No distance is covered. Now as we move, when time is 1 second, so when t equals to 1, the displacement becomes 0 and the distance is 3 because 3 units have been moved by the particle. Is this part clear to you? Right? Next second, what happens? So this is not to the scale. I'm just trying to fit in the values. Next second, what happens is t equals to 2, right? So at t equals to 2, we do have a maximum value of 1. So this is this value we're looking at. So at t equals to 2, it goes up by 1 more unit. So we add this 3 with 1 and we get final distance of 4 units. So you can actually add the displacements absolute values to get the distance covered, correct? So we see that at t equals to 2, displacement is actually 1 and the distance covered is 4, right? Distance covered is 4. Displacement is 1, so it is 1 unit still on the right hand side. So the particle actually moved from here to there and then to this place, correct? So that is, we have reached that place. Now you see it comes back to 0. It really means that the particle now is moving from here to there, right? So this is what is happening. It's coming back to 0 at t equals to 3. So at this time, displacement is 0 and the distance is, you added one more unit. Do you see that? You added one more unit to 1 more meter to your distance and became 5. So distance keeps on adding, right? And then when t was 5, it further moved 8 units to the left, right? So it kind of moved further. Let me use another ink here. It further moved 8 units to the left, right? So from here, imagine this, far away. So this is at t equals to 5. Displacement is minus 8. But as far as the distance is concerned, it added 8 more meters to 5 and becomes 13. That makes sense to you, right? So 5 plus minus 8, that gives you 13. So total distance in this duration, which is from 0 to 5, is 13 meters. Perfect. And that is how I can actually show it on a horizontal motion graph. So this is what I just made, is called motion graph or diagram. Is that clear to you, right? So I hope you've understood how do we find displacement and how do we find total distance, right? Now let's look into the other part, which is find initial position of the particle and identify the time interval when the particle is to the left of O. So the particle started at O. So particle t equals 0, but particle's reference displacement is from the origin O, right? So displacement is from origin O. When particle started, it was minus 3 units to the left. You see that. So it says, find the initial position of the particle. Initial position means, we are answering B. What happens when t is equal to 0? So S of 0 is equal to minus 0q plus 4 times 0, right? Minus 3 gives you a value of minus 3. So initially it is 3 units to the left of origin, right? So it is 3 units left. Units are meters for us, left. Left of our reference point, which is origin. So when we say position, then position is with reference to origin. O, you get the idea. So on a horizontal line, we will show the origin with O and the position as minus 3. You get the idea. That is what we are saying on the left side. So find the initial position. This is the initial position which is at t equals to 0. Perfect. Now identify the time interval when the particle is to the left of 0. So what is happening here? It is left of 0 only in the interval where the displacement is negative. Do you see that? So to answer part C, we say identify the interval when the particle is to the left of 0. I should say O, left of O, the origin, okay? So it is on the left of origin when the displacement is less than 0, means negative. So it is from t equals to 0 to 1, right? And use for union from this point, which is 3 to 5. So during this interval, the object is to the left of origin. Do you see that? left of our reference point, which is origin. Is that clear to you? Correct? Now let's look into how do we sketch the motion graph of this particular situation, right? So we have got very critical values already. So we know at t equals to 0, we have s equals to minus 3 and the displacement d is equal to 0, correct? At t equals to 1, when you plug it in here, we know at s is equals to 0 and the displacement is equal to, it has covered 3 units, right? Distance. At t equals to 2, s is equal to 1 and distance is added by 1 more, it comes to 4, right? At t equals to 3, we have a displacement of 0 and distance again added by 1, it becomes 5. And t at 5, displacement is minus 8 and distance is adding 8 to 5, which is 13, right? All in meters. You see this position, right? Now we are going to, on a motion graph, show the displacement basically. Displacement is position with reference to a reference point O, right? So let me write down what is displacement. So displacement is position from reference point O, right? That is what displacement is. So let me draw a line here. Now in this particular case, most of the data is on the left hand side. So I'll put O here. That is my origin. Origin here means the reference point, right? So this is my reference point. So do not get confused with the origin otherwise, but this is the reference point, right? Which is the 0 for our number line, straight, rectilinear motion. So at the starting, what is the position? Minus 3, right? So this is minus 3, which we are representing on this side, right? So this is left side, right? So this position is minus 3, and that happens at t equals to 0. Is that clear to you? So the object really starts from the left of the reference point. So the graph is the movement from here to, as we see from t0 to 1, it goes to 0. That means it goes from minus 3 to this. And then further one more unit, right, next second. So, and it reaches a displacement of 1. So this is where it reaches displacement of 1. And then the next second, it comes back to 0, right? So it covered 3 units and 1, 4 units. And then it comes back to 4, right? So it comes back. So let me draw it with another line here. It comes back like this. You see that? Comes back. So that is your coming back from here to here. And then this is coming back, which is right there, right? And then goes further down by 8 units. So from here it goes to minus 8. So minus 3, let's say minus 8 is here, right? So that happens at t equals to 5. So this is your graph along a straight line. And clearly what you notice here is the duration when it is to the left of this origin, right? This is at t equals to 1, that is at t equals to 2. And then t equals to 3, right? And this is at t equals to 5, which we have already written. You understand this motion graph? That is how we are going to draw it. Perfect. So I hope you have understood the complete concept of a particle traveling along a straight line for a given equation and a duration. Important thing is, if the displacement is negative, then the object is on the left side of our reference point O, and when the displacement is positive, it is on the right hand side. And distance actually is the total of all the displacements covered during this period. So I hope that helps. Feel free to write your comments and share your views. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.